Hi, everybody. I'm Bob Thronson with Vigilent, and we're honored to be a TiE 50 startup finalist, so thank you for the opportunity to tell our story. So I'd like to talk about putting the why in IoT. It's a little play on words, but you know, there's a lot of buzz about IoT and sort of why are we doing this and what's it all about. And Vigilent has an IoT solution that optimizes data center cooling. I'll be talking about that. So you've all seen, you can click again, the Gartner hype cycle comes out every year, and Internet of Things is like super at the top of the hype cycle right now. So every conference, including this one, has an IoT track. You know, every magazine, analysts, and conferences, they're all making a lot of money off IoT. So that's great. But that doesn't mean it's bad. I mean, it's just there's a lot of buzz around it. And most of the buzz is around these consumer-type products. Self-driving cars, the Apple Watch. I don't have that yet, but I keep on wanting to get it, waiting for the killer app, Nest, things like that. And these are all sexy and really exciting. But, and you can click a couple more, please. But, you know, McKinsey did a study last year where they looked at where the IoT opportunity is over the next 10 years. And what they found is that 70% of the IoT value they expected over the next 10 years will be in boring business-to-business type applications. And the biggest area there was called factories. And they defined factories as manufacturing and data centers. And this was the range up to 3.7 trillion in incremental economic value through IoT type applications. And within that, the greatest potential was in operational optimization, right? Dynamic operational optimization, and also predictive maintenance. So what Vigilent does is actually exactly this in data centers, in the cooling and environmental and energy part of the data centers. And there's the data center. So, and they all look very different, but this nice picture of one. So what we do is use an IoT approach to optimize cooling in data centers. So cooling's difficult to manage. You can do a few more clicks, please. That's good. And what this is actually the state of California government's largest data center. It's in Sacramento. It's 43,000 square feet. You know, these are all these racks here. You know, this thing's huge. And each of these little triangles is an air conditioner. And I think there's like 28 of them in the room. And they're the size of SUVs. And in most data centers, those air conditioners are on all the time, and they're blowing cold air, unless they're broken, they're blowing cold air all over the room, okay? People are they spend a lot of money on cooling, they're blowing all cold air in there, and generally the room's pretty cold. But it's actually really complicated to manage this environment properly, and the reason is, when you turn on an air conditioner, it doesn't just like, you know, I thought when I started at Vigilent, it cools the area around it. It blows air around in a lot of unusual and unpredictable ways. So this particular air conditioner, when you turn it on, it actually cools around here, over here a lot for some unknown reason because of airflow. And if you can see on the slide, there's other blue areas, and it heats up these areas. Now that's just one air conditioner, and who would have predicted that? And this is actually measured data from sensors, temperature sensors out on the floor. Click again. Now this particular air conditioner has a more localized effect. Again, this one has like almost no effect in the room. It might be broken. And then the last one. This particular air conditioner has a huge cooling influence throughout the entire floor. Now all these are the same manufacturer, same make and model, were purchased at the same time. Some are like, it's like a fleet of cars. Some have greater influence and perform better than others. Others are lemons and broken. So in this kind of environment, how do you possibly optimize this as a human being trying to figure out what units to have on, what fan speeds to have? You just can't do it. It's a huge, very complicated problem. So what Vigilent does is we deploy wireless sensors or can use other people's sensors out on the floor, and then we deploy machine learning software which figures out the influence using these sensors of every air conditioner throughout the entire floor, and then overlays these influence maps, which we call them, and then automatically and dynamically controls cooling in the room to make sure that all the temperatures at all these racks are where the customer wants, and it does it in the most efficient way. So that's what we do. So just to show you that when that happens, what the impact, economic impact can be, this is a typical like data center with 10 air handling units. And instead of having fans at 100%, they've turned them down to 85% just to save a little energy. That's what a lot of people do. Now what the Vigilent system does is controls each one based upon its understanding of the performance of the unit and its influence across the floor. It will determine, for example, this HU5 has a huge influence and should be at 100%. This one, HUH, is broken. You need to turn it off, just save energy there. And others may be at other speeds. And when you do this, this is the kind of impact you get. Remember, I mentioned all the air conditioners on in a typical data center. Air is blowing all around. That's just cold air. The hot air from the servers is blowing around into the front of other servers, which you don't want. So there are a lot of hot spots, even in generally cold data centers, because of this airflow dynamic. So Vigilent eliminates virtually all of those hot spots automatically. And the other benefit, again, thank you, is that not only does it eliminate hotspots, which improves the reliability of your facility, reduces the risk of an outage, it does it in a very efficient way. And this is a 40% cooling reduction. And across our global deployments, we have a 38% reduction in cooling energy that happens within the first few days. So the system optimizes data center environmentals and pays for itself with energy savings. Okay, next. So, in addition to the sort of dynamic control, what we've done in the last year is also invested in analytics for more management decision making. And this just gives you an example around capacity and CapEx investment. So we had a customer that has a bunch of data centers, and every year they spend $20 million to replace 20 of these huge air conditioners. And the way they've done it is take the oldest ones and replace those. Makes sense, right? But as you've seen, air conditioners, just like cars, some last a lot longer than others break, whatever. That's not the right way. You should make data-driven decisions, which is what we help with. So one more click. So here's like a list of air conditioners, and what our system will do through analytics is determine the exact performance of each of these units. So they can see the ones that actually need maintenance or replacement. But even more interestingly, they can see the influence of those cooling units, remember, across the room. So these areas actually may be really cold, but what this shows is a lack of cooling redundancy. So you may have one cooling unit cooling this area. It's really cold, everything's great. But if that unit were to break, you'd have a serious heat problem. So the system can provide these sort of insights and analytics that without the machine learning, you never would get. And you can make one more click. Yeah, low redundancy there. And so they made, one more please. So what they did is instead of investing $2 million in 20 units, they realized they only needed to replace 5 for a quarter of the cost, and they had $1.5 million to invest in other CapEx projects in the business. So that's another area of value we're providing through our new analytics that we've done over the last year. Okay. So this is a list of some of our customers. We have customers across 4 continents. This year we expanded into some new markets like Itaú in Brazil, which is the second largest bank down there, and EGA in Thailand. This is sort of how well we've done. We're up to 409 deployments. We are hoping, we were under 300 a year ago, and we're hoping to get to over 1,000 by the end of next year. And these are interesting numbers, big energy savings, but the number that our employees are most proud of is actually this right here, is the 211,000 tons of CO2 reduction. We're like kind of a clean tech success story and take a lot of carbon out of the atmosphere. And so everybody's very proud of that. And of course, what really matters in the end is what the customer says. And here's an example. The Chief Sustainability Officer of Verizon is with Vigilent. We cut 55 million kilowatt hours, which, by the way, at about 10 cents each is about $5.5 million of electricity in our data centers, translating to 38,000 metric tons of CO2, good for business and the environment. So that's what Vigilant's about. Thank you very much.